So we are starting with skewness, as we had a brief discussion regarding skewness. Okay. This is a distribution, a normal distribution, and this is exactly the symmetry. Okay. That means 50% of the data lies this side, that is right side. If this is the mean, let's say it is 0, this side shows the positive, this side shows the negative. This is 50% of the negative area, 50% of the positive area. This is symmetry.
Okay.
But when this symmetry is, you can see this symmetry because everything is balanced here. Okay, that's the reason why this is in symmetry. But if things are imbalanced, kind of, if you see lot of data sets or lot of clustering in the extreme sites, okay, that means you see most of the outliers make the normal distribution curve to get skewed. So this is a shape which shows you skewness. This is positively skewed, and this is the shape which shows negatively skewed curve, normal distribution curve. This is called this due to negative skewness. That means most of the data is here lying in the extreme tail, and here also most of the data is lying in extreme tail. But here you see it's in negative side. Here you see it's the positive side. This is positive skewness, negative skewness. And you see, like, let's say, suppose you are expected to come to office always at 8 a.m. Okay, you always come at 8:30 or 8:45 or 9. So what do you say? You can see that the data is in the extreme right outlier side, correct? Okay. If I speak about returns, if the returns expected from a particular security is, let's say, 10%, you always get returns 20, 22. So I can say that is positively skewed. If you see, you expect the returns 10%, if you get -5, -10, or you get -1, so it is negatively skewed. Okay, I hope you understood, correct?
Yes.
Now let's do some reading here. A distribution is symmetrical if it is shaped identically on both sides of its mean. As I told you here, distributional symmetry implies that intervals of losses and gains will exhibit the same frequency. Okay. For example, a symmetrical distribution with a mean return of 0 will have losses in the -6 to -4 interval as frequently as it will have gains in the +4 to +6 interval. That means either here 4, 6, or -6, -4, -6. You understood? So this is symmetry. Hello?
Yes. Please go.
Yeah, I'm going ahead. Okay. This is symmetry. Now, the extent to which a returns distribution is symmetrical is important because the degree of symmetry tells analysts if the deviation from the mean are more likely to be positive or negative. So that is what you can really understand, like, in which side you are. Okay, you are not like inclined towards just one side, unlike in the skewness you are just to one side, or you are just to one side. But here, if you are in this side, it makes the analyst to understand that you're in the positive side. If you're in this side, it makes the analyst to understand that you're in the negative side, correct? Now, as I have already explained you about the skewness in this too, I have explained you with very good example, and here you can see outliers are the observations extraordinarily far from the mean, either above or below. Correct, Abhijit? Is it clear?
Yes.
Now, positively skewed distribution is characterized by outliers greater than mean in the upper region of right tail, and positively skewed distribution is said to be skewed right because it is relatively long upper right tail. So as I said you, the data lies here at the extreme, and here in the extreme in the negative side. So it's negatively skewed. Fine. Now, skewness affects the location of mean, median, and mode of the distribution. We can see that with this figure. This is symmetry. This is skewness. Okay, you can always see the mean being at the extreme right, not at the tail, of course, but in the rightwards, because this is the one which gets affected because of the outliers. These are the least affected ones. Mode is almost not affected at all. Okay, and since it's a positively skewed figure, you are seeing your mean is at the extreme right, and here your mean is at the extreme left, and that you can understand with the help of this example. So there's an example here of positively skewed distribution is that of housing prices. Suppose you live in a neighborhood with 100 homes,
Okay.
99 of them, sorry.
Yeah, sorry, sorry. Go ahead. Go
Okay,
ahead.
you said okay. Sorry, I didn't hear. I was in my flow. So there are some 100 homes in a neighborhood, and 99 of them sell for 100,000, but one sells for $1 million. So the median and mode will be 100,000, of course, and the mean will be this. Why? Because when you calculate for 100 homes taking 100,000 and just one observation as 1 million, then you can get this figure, and that shows that mean is going towards the right side, which is more than the median and the mode in this case. Okay, so in negatively skewed, the data would be negatively in the extreme side. So in the sense, you'll be having one of such observation which would be outlier and which would make the like mean to be in the extreme left. Okay, as you can see here. So your data will be like -10, like -1, -2, -5, -10, and one will be -100, let's say. So this will make the data to be in the extreme, in the left side, but mean would be at the front here. Okay. Now, because of the outlier, and skewness formula is this, whereby it's the summation of the like cube of the deviations from the cube of the mean deviation from the sample. Okay, so sample skewness is equal to the sum of the cubed deviations. So this is cube and this is deviation, cube deviations from the mean. So square deviations can be variance, correct?
Yes.
Square deviations, and normal deviation is mean. Okay, normal deviation is mean. And so this is called the first moment. This is called the second moment. Moment is nothing but it shows the shape, the range of the distribution. Okay, moments are nothing but those deal with the shape of the normal distribution. Those show the shape of the normal distribution. That shape changes because of the behavior of the data sets which you show or depict on the normal distribution curve. Correct. So if the data set is more towards the outlier, that means more towards the extreme, both sides, it is kurtosis, fourth moment. If it is more near to the mean, again it's kurtosis, because kurtosis can be two types, leptokurtic, platykurtic, will be going to that. Okay, and both the sides equally, that is mean, that is first moment, and deviation from the mean both the sides, that is variance, second moment. Okay, and then third moment is skewness, and the fourth moment is kurtosis. They haven't given you all this, but it is like in the FRM book you can see all these things. Basic statistics is not there in FRM right now, they have deleted, but somewhere they have included all this. Okay, in the distributions chapter. Now, so this is like the standard deviation cube in the denominator, you can see. Okay, divided by the cubed standard deviation by the number of observations. This is the formula for sample skewness. Note that the denominator, see, one thing I would like to tell you here, the denominator is always positive, but the numerator can be positive or negative. See, if I take -1 whole cube, it is -1. If I take 1 cube, it is 1. So the data can be either negative or positive in the numerator, correct? But the denominator, standard deviation, you always get root of variance, and negative roots won't exist, correct?
No, negative.
So since negative root won't exist, there is no chance of getting negative in the denominator. That's it, simple. So yeah, so can be positive or negative depending on whether and above the mean or observations below the mean tend to be farther from mean or average. Mean on average, when a distribution is right skewed, sample skewness is positive because deviations above mean are larger. On average, left skewed is negative. Okay, that we already discussed. Dividing by standard deviation cubed standardizes the statistics. See, why you divide with standard deviation? To standardize the data, to normalize the data. Understood?
Yeah.
Okay. Because there will be deviations. When there will be deviations, we show those on the normal distribution curve. And allows interpretation of skewness measure. Okay. If relative skewness is equal to 0, the data is not skewed. Positive levels of relative skewness imply a positive skewed distribution, negative. That's understood fact. Value of sample skewness in excess of 0.5 in absolute value are considered significant or important. That is standard. Now let's go for the kurtosis. See, kurtosis has to do with the shape actually. Okay, is a measure of degree to which a distribution is more or less peaked than a normal distribution. You can see the curve here. This particular is the normal distribution. This is leptokurtic because more data is very near like to the mean. Most of the data lies here. Most of the clustering is happening here. That makes your normal distribution curve to get peaked, and that becomes the leptokurtic kurtosis, correct? Second.
Mm-hmm.
And platykurtic refers to a distribution that is less peaked or flatter to normal distribution. So we can say this. And one more thing we'll discuss, mesokurtic is if it has same kurtosis as normal distribution. So if I make a particular curve exactly with the normal distribution, it's mesokurtic. But if I make it in this way, more flatter, it is platykurtic, correct? Because most of the data is clustered here, and that pulls this normal distribution curve to the extremes and makes the tail more flatter. Okay, hence that is platykurtic. This one. Okay, that is done. And let's go for the, see, excess kurtosis. Actually, a kurtosis should always be at 3. That is standard. What is that?
Standard.
But if at all your kurtosis is 5 or 6, then you should find out the excess kurtosis. That is nothing but sample kurtosis minus 3. That is excess kurtosis, correct?
Yes.
This I and you did not make it. This is a standard. Okay. And the formula for kurtosis is always this. That is the power 4 of the deviations divided by the power 4 of standard deviation. And always we divide with standard deviation to normalize the data. Okay. And that's what it is. Excess kurtosis has been explained to you. Now let's go for the next topic, that is covariance. And before going to that, Abhijit, I would like to ask you, have you gone to the portfolio management video? Why? Because you'll be having covariance also as well in that.
Yes. So I have gone through the first part. I have to finish the second part actually.
You're about to finish?
No, I finished like 25%.
Okay. And one more thing I want to ask you. I think the video was very clear to you.
Yeah.
Explanation was very clear, correct?
Yeah. Yeah.
Okay. Then I'll give you the next 3 today. Okay. Sure. So what is this covariance, Abhijit? Any idea about covariance?
So what I mean? So
See
how?
what happens. Yeah. If any idea you can discuss.
Yeah, yeah, please go.
Otherwise, I'll go ahead.
Please go.
No. See, please involve yourself. If you have any idea, just give me any rough idea.
So how closely related the variables are?
Yeah, you are very near to that. We generally see the relationship between two variables in covariance. Of course, that means we see how they co-vary. Okay, suppose I take the I take Sensex. That is BSE, Bombay Stock Exchange, Sensex, okay, which roughly has the companies in that. And this is this is what we are seeing, the returns what we get from Sensex. Okay, returns from Sensex. Okay, let's go in this afterwards. I take 2 stocks, HDFC Bank and SBI Bank. Okay, both are from the both are banks. Okay, have similar kind of business. Now what we want to say is, if I make a portfolio of HDFC and SBI together, I want to see the relationship between these two, how they behave. Since this is a more established one, this is a more profitable one. If SBI moves up, if the SBI stocks price moves up, how does HDFC behaves with respect to that or in relation to that? That means, does HDFC also goes up? So what kind of relationship they have?
I mean, if they go up together, it's positive.
Positive. This is what I'm just roughly speaking to you, but I need to quantify that relationship. To quantify that relationship or to give a number or to prove what kind of relationship they have. If I get a positive number, if I calculate covariance, that means they have a positive relationship. That is a confirmation, correct? So if SBI goes down and HDFC as well goes down, what kind of relationship they have?
Yeah, positive correlation.
Still positive because both are going in the same direction. Okay, then here I should in the sense whatever the case is, if these two stocks go down, I should get a positive relationship. That means a positive number will come in this case as well, and that positive number will show the positive relationship between them. Okay, if SBI goes up and HDFC goes down, definitely your covariance number will be negative, and that would depict or show that there's a negative relationship with these two. So there is conformity about the relationship. Okay, so let's do a small example and calculate the covariance. What is happening here, and then we'll go for the correlation. So let's take a small data.
Yeah, actually,
I have
your
it.
voice is breaking and you're not audible.
Sorry.
Your voice is breaking and you're not audible actually.
Yeah, see, today there was heavy rain in Hyderabad, so some network issues may be there. See, actually, I don't have power at my home. The power backup is there, so we have Wi-Fi also connected to it. So I'm taking the class. Don't want to miss even a single class for you. That's the need of the hour. So now I'm audible to you.
No, actually, I mean.
No, I got today. It was cyclonic rain, Abhijit, and I was stuck in that. You know, hailstorms. Literally, they fell on my car. So I just got escaped today. Uh, Now, am I audible to you?
Yeah, it's better. Yeah.
Okay. So now I'm taking a stock. Okay. I'm taking a stock as Y, stock Y, stock as variable Y, and I'm taking Sensex, that is returns of stock, returns on stock as variable Y, and return on Sensex. That means I've taken the Sensex stock, BSC stock, as I'm taking as X. Okay. And I'm going to find out the covariance now. Let me take X and take Y. I have already mentioned you what they are. Okay. So X is 12, Y is let's say 18, then 25, 30, minus 10. Negative returns as well. It has given 6 and Y 22 and then 16 and then 35 and then 45 minus 30 and 12. Okay. Then we'll do Y minus Y bar, X minus X bar. Then we will multiply X minus X bar into Y minus Y bar. Okay. So just do the calculations and tell me, Abhijit. Hello.
Yes, sir. Yes, sir. Yeah, I'm writing it down actually.
Yeah. And then what is this meaning of bar, Abhijit?
Average.
Sorry, average. So take out the average. And tell me the average, and also take the deviations and tell me the values. I'll put it there.
18, 25. Okay.
Abhijit, just continue just a second. So average is like, okay, you're calculating, huh? Fine.
Yeah, for average for the first column, I'm getting 13.5. And the second column is 16.83.
Okay, Abhijit. So you can go for these calculations and then you tell me what is the total. Sorry.
Nothing.
Yeah. So you should take y minus y bar 22 minus 16.83. What you're getting here. Tell you should like see what's the value and values. Okay. I'll calculate on my side. You do on your side. I got 16.67 roughly. Okay. I got that. You got 16.83. Okay, that's nearby. X minus x bar.
See, X is 12 and X bar is 13.5. How do you get a difference of minus 4.67?
I'm just checking out 2 minutes. 12 minus. It's like somewhere around 1 point something I'll get. That's not a problem. Huh? From calculator we can do. I just put it to some figure which I have in the book. Okay. Need not worry about that. You calculate. Okay, fine. You do that. I'm waiting for you. Tell me the figures.
Yeah, just calculate. Yeah, minus 1.5, 4.5.
I'm writing. Yeah, tell me. Minus 1.5.
4.5.
4.5.
Yeah.
Okay.
11.5.
Okay.
0.5.
Sorry.
16.5. Minus 23.5. And negative 7.5.
Okay. Now multiply these two and tell me the total of this. Okay, fine.
I have to multiply, okay. And
X minus x bar and y minus y bar, and you have to do the summation of that.
I am getting a sum of 1810.5.
Here the total
1810.5.
Okay, so we got 1810.5. That is x minus x bar sigma into y minus y bar. We have to do divide. We have to divide by n. So number of terms 6. So what are you getting here?
301.5.
301.5.
1.5.
So what does it mean? We got a positive number, so they have a positive relationship, correct? No,
Yep.
that's what is covariance. So now this covariance we got, fine. Why are we then going for correlation? What happens with this covariance number is the problem with covariance is we got 301.5. We would get 1 million as well. Okay, but even though we get 1 million, even though we get 2, even though we get number as 5, even though we get any number, it will show just what kind of relationship these two have.
Direction.
Positive.
Yeah.
But they cannot tell us about the strength of the relationship. That means if I take this example about the returns on Sensex and returns on stock, I can just tell that they have positive relationship, but I cannot tell the strength of the relationship between them. That means if Sensex would increase, by what percent or how much percent chance is that the return on stock would also increase? So I'm not able to say the strength of the relationship. This has been resolved with the help of correlation. So correlation tells about the strength of the relationship between two variables. Just make a note of this.
Yeah.
So even though whatever numbers you get, it doesn't matter. The correlation, the covariance will just tell the direction or the relationship, but it does not tell the strength of the relationship. Okay. So let's say what I'm doing for correlation is, so correlation is what? Correlation is covariance of these two variables x and y divide by standard deviation of x into standard deviation of y. Just make a note of this. But why am I dividing with standard deviation?
Just one second. Let me just write. Why are you dividing with standard deviation?
Yeah.
I
I'm doing that to standardize the data. That means I just want to put this data in a scale of -1 and +1. Okay. So I have to normalize this data. To normalize, I have to, or to standardize, I have to divide with standard deviation, correct?
Yeah.
So correlation is such a measure which always is between -1 and +1. It cannot go beyond these two. It's a scale. And to normalize this data or standardize this data, we have to divide with the standard deviations of both the variables, correct? So that
Okay.
we can put that in a scale or in a range. Okay. So now let us now find out the standard deviation of these two data. So can you do that standard deviation for me, Abhijit, for these two? We have already discussed standard deviation, how to calculate. I want you to calculate right now.
Want me to calculate for X or Y? Both or both?
Both. We should want for both. Now we should put for both. Isn't it so?
Calculator.
Sorry.
Use a calculator.
Yeah, why not? You can use Abhijit. See, you know the formula now. Standard deviation first x minus x bar the whole square divided by n. Then y minus y bar the whole square divided by n. Whatever you get, you just put square root to that and tell me. That's it. We'll immediately see the answer for this. We'll get the answer.
For the first set of values, I'm getting 13.13.
13.13. Okay. For y, for x or y?
For
For
X.
x. Okay, so I'll just put that there now. So we got, what did we get the correlation covariance then? We got 10 something, correct? No, this was the total divided by n we did now. We got 301.5. Okay. So we'll take it here. 301.5 divided by, yeah, tell me for x 13 point. 13 into for y also you calculate and tell me.
Calculator 23.82.
Just divide and tell me what's the answer you're getting. Correlation is denoted by R. So R is equal to
0.96.
sorry.
0.96.
That means the correlation is exactly coming between these two, and it's almost a perfect positive correlation. That means if SBI increases or decreases, there is a 96% chance that SDFC will also increase or decrease. That's it. Finish.
Yes, sir.
That's it. Okay. So this is what we wanted to find out with correlation, which the covariance wasn't telling us. So covariance deficiency has been rectified via or through correlation. Finished? Fine. This is the end now. So 96% chance that if SBI increases, the SDFC would also increase. Okay, then find out this one. Finish this. We'll move forward. Just one, I think one paragraph we have, that's it.
Variance of a stock is 0. Yeah, I mean, it's a straightforward question. Okay. They are not given the standard deviation, but they are given a variance. Okay, no problem. I think you can move. Hello.